Students, next let's we move to the exercise 1.4. The first question, classify the following numbers into either terminating or non-terminating recurring decimal. The first subdivision 13 by 3125. To classify it into either terminating or non-terminating, the first step is to check whether the both numerator and denominator are co-prime numbers. Okay, so co-prime means both the numerator and denominator should not have a common factor other than 1. Okay, see here it is 13. Okay, 3125. 13 is a prime number, but 3125 is a composite number, so we have to prime factorize the denominator. If both numerator and denominator are composite numbers, then we have to prime factorize both the numerator and denominator. But here in this subdivision 13 is a prime number, so we have to leave the numerator, but see the denominator is a composite number, so we have to prime factorize the number 3125. Okay, then by 3 1 12, so it is not divisible by 3, so go for 5, 30 6 times, balance 1, so 12 2 times 5, so it is 625. Again dividing it by 5, I will get 1 2 5, then divided by 5, it is 25 times, and again by 5 it is 5 times, again by 5 1 time. Okay, so 3125 is written as 5 into 5 into 5 into 5 into 5, so that is 5 power 5. So here in this question the denominator is in the form 5 power 5, so it is in the form 5 power m into 2 power n, where m is equal to 5 and n is equal to 0, because 2 power 0 which means 1, so 5 power 5 into 2 power 0, that is 5 power 5. Okay, so it is in the form 5 power m into 2 power n. So when a number is in the form p by q and q is expressed in the form 5 power m into 2 power n, then I can say that the decimal value of this fractional number will be terminating. Okay, so 13 by 3125 will have a terminating decimal value. Next, the second subdivision 17 by 8. Here 17 is a prime number, but 8 is a composite number, so I have to pick the denominator and prime factorize it. So 4 2 2 2 1, so 8 can be written as 2 into 2 into 2, which means 2 power 3. So the denominator is in the form 2 power m into 5 power n, where m here is 3 and n is 0, because 5 power 0 means 1, so 2 power 3 into 5 power 0 gives 2 power 3. Okay, so it is in the form 2 power m into 5 power n. So according to the theorem 1.6, I can say that the decimal value of this number will be terminating. Okay. Next, the third subdivision 64 by 455. So it is already in most simplified form. So just we have to take the denominator and prime factorize it. On dividing by 5, I will get 9 1. So it can be divided by 7, it will be 13. So by 13 1. So 455 is equal to 5 into 7 into 13. So it is not in the form 2 power m into 5 power n, where m and n are non-negative integers. So according to theorem 1.7, I can say that it will have a non-terminating recurring decimal. Next, the fourth subdivision, 15 by 1600. See, it is not in most simplified form. So we have to take the numerator and denominator and prime factorize these numbers. So I have to prime factorize 15 and 1600. So 15 by 3 I will get 5. So 15 is equal to 3 into 5. Okay. So 1600 by 2 I will get 800, by 2 400, again by 2 200, again by 2 100, by 2 50, by 2 25, so 5 5 1. So 1600 can be written as 2 power 1 2 3 4 5 6. So 2 power 6 into 5 power 2. So I can cancel these numbers, becomes 1. So it is 3 by 2 power 6 into 5 power 1. So the denominator is in the form 2 power m into 5 power n, where m here is 6 and n here is 1. So both m and n are non-negative integers. So according to theorem 1.6, I can say that this value will have a terminating decimal value. Next, the fifth subdivision, 29 by 343. See, both are co-prime numbers. So they are not having any common factor other than 1. So I have to prime factorize the denominator alone. 343, on dividing it by 7 I will get 28 4 times and 63. So it is 9 times by 7 7. So 343 is equal to 7 into 7 into 7. So it is nothing but 7 power 3. Here the denominator is not in the form 2 power m into 5 power n, where m and n are non-negative integers. So according to theorem 1.7, I can conclude that it will have a non-terminating recurring decimal. Next, the sixth subdivision, 23 by 2 power 3 into 5 power 2. So they have already given in terms of 2 power m into 5 power n. So the denominator is in the form 2 power m into 5 power n, where m is equal to 3 and n is equal to 2. So both m and n are non-negative integers. So according to theorem 1.6, it will have a terminating decimal value. Okay. Next, the seventh subdivision, 129 by 2 power 2 into 5 power 7 into 7 power 5. See the denominator carefully. It is having the factors 2 into 5, right? So it is having 2 power m and 5 power n, but it has some extra factor 7 power 5. So it is not in the form 2 power m into 5 power n, because the denominator should have only the factors 2 and 5 to be terminating, but it has 2, 5 and 7. So the value will be non-terminating recurring. Next question, question number 3. Classify the following numbers as rational or irrational, and if it is irrational, then discuss about the prime factors of the denominator. Okay. So the first question is 43.123456789. So see this decimal number, it is terminating, right? So you can say the exact number of digits after the decimal point. So it is a terminating decimal value. So if it is a terminating decimal value, according to theorem 1.5, it is a rational number where both the numerator and denominator are co-prime numbers, and the q, the denominator, will have the prime factors in the form 2 power m into 5 power n, where m and n are non-negative integers. So they have given a terminating decimal. When you apply the theorem 1.5 here, then it can be expressed in the form p by q. So if we are representing a number in p by q form where p and q are co-primes, then it is a rational number. And when we further apply the theorem 1.5, it states that the denominator, the q value, will be having the prime factors in the form 2 power m into 5 power n, where the m and n are non-negative integers. Next, the second subdivision, see here, it is a non-terminating decimal value. See here, it is a non-terminating decimal value. Whether see it has repeating digits 1201, here 2001, here 20001. So it is not repeating. So it is non-terminating, non-recurring decimal. So if it is a non-terminating, non-recurring, it is a irrational number. So if it is a irrational number, it cannot be expressed in the form p by q. So we cannot discuss about the prime factors of the denominator. Okay. Next, the third subdivision, see here 43.123456789, the bar. So it means that it is not terminating. So it is not terminating, but it is repeating, right? It is non-terminating, repeating decimal. So non-terminating repeating decimal will leads to a rational number. So it is a rational number. So it is a rational number, it can be expressed in the form p by q. When talking about the denominator, see it is having non-terminating repeating decimal. So definitely it is a rational number. If it is a rational number, then it can be expressed in the form p by q, where both p and q are co-primes. So the factorization, the prime factorization of the q will leads to 2 power m into 5 power n, where m and n are non-negative integers. Okay. So this is all of the chapter 1. Students, you can solve the second sum in exercise 1.4. It is nothing but in question 1 we have seen whether to classify the numbers into terminating or non-terminating decimal. In that question, the values which are coming under terminating decimal that has to be divided and the decimal values have to be calculated. That is your second question. You can do it by yourself. Okay.